Hello class, today we'll be talking about 11.2 permutations. So the objective today is to use the fundamental counting principle to count permutations, evaluate the factorial expressions, use permutation formula, find the number of permutations in duplicate items. So first thing we want to look at is the definition of permutations. Permutations is an ordered arrangement of items that occur when no items are used more than once, and the order of the arrangement makes a difference. So that means that the order matters. So remember that order matters, or the arrangement matters when you deal with permutations. So, you need to arrange 7 of your favorite books along a bookshelf, a small shelf. How many different ways can you arrange the books, assuming that the order of the books make a difference? So, what I tell people is to make sure you keep your track of what you're using. You go ahead and draw some dashes. Usually, I do boxes. All right, so if you see, I drew 7 dashes. So for the first choice, how many different ways can I put that first book? 7 different ways. What about the second book? It's 6 different ways. The third book, I have 5 different ways. Then I got 4, 3, 2, 1. So now if we look at this, remember, we subtracting 1 each time because we already put a book down. So it's 7 times 6 times 5 times 4 times 3 times 2, which should give you 5,040 different ways that you can arrange this bookshelf. So when you're doing these problems, make sure you're paying attention to what you're doing, because you want to make sure every time you get rid of one, you have to make sure you keep that in mind. Now, another way of looking at this is factorial form. So the product of 7 times 6 times 4, it's times 5 times 4 times 3 times 2 times 1 is called 7 factorial. Now, the factorial, you may have seen it before because it's an exclamation mark in English. Now, factorial says if n is a positive integer, the notation in factorial reads, in factorial, is the product of all positive integers from n down through 1. So you're basically reducing everything down to 1. And by definition, 0 factorial is 1, because that's the last number it could possibly be. So let's actually look at a couple of problems which we will do by hand. So we got 8 factorial over 5 factorial. Now this can be done in the calculator, but I'm going to show you how to do it by hand. So I can reduce this. This could be 8 times 7 times 6 times 5 factorial. Now, I stopped at 5 factorial because we're dividing by 5 factorial. Since we're dividing by 5 factorial, I can go ahead and cross these 2 out because I'm dividing by 5 factorial and I'm multiplying by 5 factorial. So therefore, when I were to rewrite this, this is just 8 times 7 times 6. So keep this in mind when you're doing these problems. So, and when we multiply this together, we get what? 336. So it's 336 it'd be 8 factorial over 5 factorial. Now we have the next one. Now I'm going to do 26 times 25 times 24 times 23 times 22 times 21 factorial. And you see that I stopped at 21 factorial because 21 factorial is on my denominator. Now, I go ahead and cross out the 21 factorial. And now you just multiply everything that's on top, and that should give you 7,890,600. So basically, all you did is multiply 26 times 25 times 24 times 23 times 22, and you should have got 7,893,600. Now, the factorial button is in your calculator. It's up for you to go ahead and find that so you can use it. Now, let's look at the formula for permutations. It says the number of possible permutations of R items are taken from N items is NPR. Usually I say NPR is NPR. So NPR is equal to N factorial over N minus R factorial. So you're going to subtract R from N. You will subtract R from N, then take the factorial. So take a minute and write that down. So let's look at a problem. So we have you and 19 of your friends decide to form a business. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? Now, remember, it's 19 is you and 19 other people. So your N in this case is equal to 20. Your R, you're choosing what? 3. So it'll be what? 20 pick 3. So it'll be what? 20 factorial all over 20 minus 3 factorial. What's this would be 20 factorial all over 17 factorial, which is equal to 20 times 19 times 18 times 17 factorial. Then we got 17 factorial on the bottom. Now we can do what? We can cancel out those 2. Now we're just basically doing 20 times 19 times 18. And when we multiply those together, we get what? 6,840 different ways. So make sure if you got any questions about this, you make sure you hit me up through Teams or you send me an email. I want to make sure you understand what's going on. Now, let's look. Now, let's say we had permutations of duplicate items. All right, it says the number of permutations in items where P items are identical and Q items are identical and R items are identical and so on by the given by N factorial over P factorial times Q factorial times R factorial and then so on. Now, me personally, I don't use the P, the Q, and the R because what I do is when I'm talking about duplicate things, I count what I actually have. So let me show you what I mean by this. So the next example, it says how many distinct ways can the letters of the word Mississippi be arranged? Now, first thing you have to do is count the number of letters that's in Mississippi, and you should get what? N is equal to 11. So me personally, what I like to do is I got M, I have I have S, I have what? P. All right, do I have anything else? That's all I have. So how many M's do I have? One M. How many I's? I have four I's. How many S's? I got four S's, and I have what? Two P's. Now, when you add all these numbers up, they should give you what? 11. If they don't give you 11, then you missed something. So, when I do this, it's going to be what? 11 factorial over, and I'm going to say I got 1 factorial. Then I got times 4 factorial times 4 factorial times 2 factorial. Now, me personally, we already know that 1 factorial is 1. All right? Then we have what? So we have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. Now, I got to understand that when you divide it and multiply by 4 factorial, you only can get rid of one of the 4 factorials. So you'll get rid of this factorial and this one. Now we're left off with 11 times 10 times 9 times 8 times 7 times 6 times 5. And this is all over 4 times 3 times 2 times 1 times 2 times 1, because that's what 2 factorial is. So all this stuff is multiplied. Now follow me. Follow what I'm about to do. So I know that if I were to multiply 3 times 2, it gives me 6. So I know 3 times 2 is 6, so I can get rid of 6 up top. Now I know that 4 times 2 gives me 8. And then we have 1s on the bottom. So right here, it's just going to be 11 times 10 times 9 times 7 times 5. And then when we multiply these things, it should give me 34,650. Now, remember, you want to always check your answer. You always want to check your answer to make sure that it is correct. So, now put in the calculator 11 times 10 times 9 times 7 times 5. And you get 34,650. So you just want to make sure when you do this, you want to make sure you correctly put your stuff into the calculator. Also, you can do this by hand or you can do it all in the calculator. Now, if you do put this in the calculator, you have to put this bottom part in parentheses. All right? And you have to put multiplication signs in between. So if you put this in the calculator, you need to make sure you have the whole bottom in parentheses, because if not, it's just going to divide the 11 factorial by 1 and then multiply everything else. So make sure you go through this. If you don't get the same answer that I got, ask me questions about it. Play with it a little bit in the computer, on the calculator. Make sure you understand what we're actually doing.